So that way the user will know that something went wrong with the connection. So if you remember correctly, the next thing that we do once we have the connection is if we either send or receive data. In the workflow diagram from the slides, we received some data from the server. So in order to do that, we need to call the receive function like we saw from those slides, and it's spelled that way, RECV. So that function looks kind of like this. So the first parameter that we pass to it is our socket, once again. And then we need some place to hold the data that we get back, so let's create a string to hold some information that we might get back from the server. So let's make that look like this. So we have a string with nothing in it, and we're going to then pass the address of that into the receive function, and that's where the data that we get back from the server will end up. So the second parameter to this receive function is the location that we want to put the actual data that we get back from our socket. And then we pass the size of that particular data. In this case, we're just going to use the size of the buffer. The size of the server response, or however much space we have to put characters in here. And then there's an optional flags parameter, which we're going to leave at 0 for right now. Since we're not putting anything fancy in there. And then the last thing that we might want to do is, since we've received data from the server successfully, we're going to print out the data that we get back. Use a format string and just let the user know what we got back. And then after we're done, we can actually close the socket with a close function. And that function is really simple. It just takes one parameter, and that's the socket once again. So that's it. This is a really basic TCP client that will print out any data that we get from a remote connection. So in order to test this, we're going to need another socket. We're going to write a TCP server to send some data to this client and make sure that that data gets printed out to the screen. And the workflow is going to be kind of the same, but there will be a few differences in terms of the functions that we need to call. So let's look at the workflow for the TCP server. Alright, so now we have our client application, but we need somewhere to have another socket endpoint so we can actually make a network connection. So we need a server side of the socket. So the API function calls and the workflow is a little bit different. So first, like in the client, we create a socket with the socket function call. It works the same way. We store it in an integer, and that basically allows us to perform some functions on our socket. But the next call is different. We need to bind the IP and port for that particular socket. So in the same way that we had a socket address that we needed to connect to using the connect function, the bind will basically specify where our socket is going to listen for connections instead of where it's going to remotely connect to send and receive data. It's a little bit different. So on the server side, we bind the IP and port using a similar structure. It'll be the exact same structure. We specify the same IP and port for the other side of the socket connection. And then we call this listen function that allows us to listen for connections. And then we call an accept function that allows us to get another socket, which basically lets us then perform these functions on the client side. So from there, we'll get another socket, another integer, and then we can call functions on that socket, like reading and writing data. So from there, after we have that client socket, we are going to call the send or receive functions, and that is how we will make data show up on the client side of the socket. We create a socket the same way, we bind it to an IP and port this time, instead of calling the connect function. And then we listen for connections, which basically will allow us to see if any sockets try to connect to our server socket. Then we accept the connection, which will return to us another socket that we can then perform the read and write operations on to get data and read data from the socket. So using a very similar structure, we can start programming our server. So let's start doing that. So we can create another C file for our TCP server. And we're going to have mostly the same exact includes as we did before. We'll need to include all of those standard library files, basically everything that we had before, because we're going to be performing mostly the same operations. A few different ones, but most of the functions that we have are already defined in all of the includes that we had before, so we'll use mainly the same ones. So once again, we include standard I/O, standard library, socket and types.h from the net package, and then net inet in.h. So first we will create a string to hold the data that we're going to send to all the clients. So we'll create a simple string to hold the text that we're going to send to any clients that connect, and then we can start creating our socket in the same way. We create an integer to hold the return value of our socket call. Then we make the socket call. It's pretty much the same as before, same parameters. Still an internet socket and still a TCP socket, so we use AF-INET and sock stream. And we can still set the protocol to 0. It's good to comment things just to keep them clean. So once again, in the same way, we define that address structure. The type is struct sock addr in